Alright, hi guys. Sorry, I just had to reopen OBS because it had to reopen OBS because it's doing a weird thing where it isn't where it isn't registering my second screen for some reason. But that's all fixed now. Yeah, just to repeat my update. Uh yeah, I my pipe burst overnight yesterday. Yesterday morning, and it was my laundry roof was raining and leaking. So yeah, I had to handle that and switch off the water main and call the emergency services. Yeah, and they were able to help me out and assess the damage. Nothing collapsed, nobody's hurt, thank goodness. But yeah, that's why I had to step out, just talk to my landlord about what we're gonna do now because a quarter of the house isn't particularly safe at the moment. Yeah, but thank you for bearing with me, and we'll get back to what we were doing yesterday. There we go. All right, so yesterday we talked about most of the first player, and then we'd gone up to the uh, the spawning of where is it? Where are we looking at? We were looking at wave spawning, and then we were looking at the enemy spawner. There we go. And so I was just going to talk you through all these various inputs that we have here. So yeah, all right, let's just follow this execution line all the way down, and then we'll just kind of do a little bit of a revision. And yeah, again, all this looks really complex, and this is my most complex branch in the whole game, but it'll make sense once you once you understand what each individual node does. It's really easy to kind of put your own mix to it. So yep, we have our enemy spawner event, and there we go. So it's for launch, it's a for loop. So for those who have done programming, they know that this is going to repeat for the number of times that it is. And so we've got a max. So our first index is the number of time is the spawned, and our last index is the max spawn. So let's come back up here because I've done something to account for this. Wait, there we go. So you might notice that the first max spawn is a 0, and there's a reason for that, because that causes only one enemy to form on screen. So I'm just gonna, there we go. We're just gonna hang out and wait for that enemy to spawn, and just one spawns. I'm gonna kill him off. Wait, and just one spawns. So that's because when computers count, they usually count 0 as a number. We as humans usually don't because we understand that it means nothing, but computers count from 0 because they understand 0 as a unit of measurement. So same difference here of max spawn being 0, that being the first number quotation marks, and let's see what happens when you perform the loop. The first check that it runs is whether it's a boss. So let's follow, if it is a boss round, what happens? The boss introduction. We send a letter to the game mode. We set it as a warning. And what I've got here, the spawn that is happening is the toothpaste. In this game, the toothpaste is like the health refill because it's supposed to be a healthy, vegetables versus candy kind of deal. So we're trying to protect the teeth. So I thought toothpaste would be good, like a tooth refill kind of health refill kind of thing. And it's that game of psychology of they give you the health refill or lots of potions right before a boss battle. So I'm creating that same feel here. Yeah, and it sets up a little warning text. For 3 seconds, it'll show on screen and allow you to collect the toothpaste. It'll turn the warning off, and it will spawn the enemy class, and it will give the player 30 seconds to kind of defeat the boss. So yeah, that's the boss introduction. That's that spawning. If it's not a boss round, and this one is a lot more interesting, we go into and figure out who we are spawning. So notice you've got the, yay, I'm getting the hang of it. We've got the actor array, but how do we choose that? So we're making an array based on the 3 enemy inputs. So we don't need to go back to, actually we should go back to the first one, because I'm going to explain something that I learned the hard way, is when you are having these inputs, you have to make sure to fill all of them. If you leave one empty, it will register it as an empty class and not spawn anything. So even if we're just spawning one enemy, we need to make sure to put, that same enemy in all 3 of these. So what that's doing is making a collection and grouping them together and turning that into a piece of information. So it's setting this array so that the computer knows that it exists. And here we're creating another array. So this is where the enemies are going to be spawning from. Now, something that I discovered while I was making these random points in the bounding box, it takes the middle of that box and expands outwards. So here we've got positive C, so it's 400 units above zero, Z0, so it's 400 units above the floor, and then 75, so that's 37.5 units up and down from that, not 75 units up from that. So that's really important to notice, because I had enemies spawning kind of on screen because I didn't quite understand how it worked. And the same thing here. It's so it's supposed to be, so it's directly in the middle, and it's going 175 units to the left and right from there. So it's kind of expanding the size of the box. So that's what you've got here, the origin, so the point of the middle of the box, and the box extent, how big it is. Very important to remember, because yeah, I was having a lot of issues trying to spawn things, and it's taking a random point. So let's say it's going negative 150 and in the axes, and positive 425. So it's just gonna spawn slightly to left and slightly up from where from the middle. So yeah, that's what that does. And let's just follow this thing, and oh wait, same difference here. Negative X 500, so that's going to be on the left side of the screen. It's got 100 units for variety of spawning, and it's 250 units up and down the page, so it doesn't spawn like off the screen and fly across. And this is on the right side. And you'll notice that I've actually got everything, despite having like really easy to read clean lines. Well, I mean, when you've got something this complex, you're going to have a few lines that are just kind of flying about, but it's really important to mark off your work, because it'd be much harder for me to pick out. So how you do that, you right click, a little box comes up, and then comment. And learn how to type and then comment. And the best thing about that is you can actually select a section. So let's say I just want these two. Right click, comment, and that will encapsulate those two. I'll just delete that for the time being because I don't actually need it. And there we go. So what array are we making here? So all sides, it's spawning from either side and the top. So we're creating an array, we're taking the output of that, the output of the top, the output of the left, and the output of the right. And we're setting that array just to tell the computer that this exists. Side spawn, kind of self-explanatory, either side, same thing, same array, except for the top. Simple enough. All right, so we've got this thing here, a switch. So depending on one of these values, something's going to happen. But what's it using? So we're going to follow this backwards, the selection, and it's the spawn locale. So in the first set of spawns, they're just spawning from the top, but let's have a look at something more complex. So this spawn locale is 2, and we'll look into that. But for now, we're spawning 0, so spawn box. So because we haven't made an array, we've just taken that top spawn box and set it as the spawn box because nothing else is gonna, we're not trying to calculate anything. We'll see in the next spawn locales what that means. So we are set, and then after that, we are spawning the AI, where you're taking that spawn box, using that as a location, and this spawn, this actor selector, what are we spawning? So it's taken that, it's taken those 3 enemies, it's made an array, and it's calculated the length of the array. So one of these 3, it is 3 items long. It's going to take a random value from that length. So it's going to say one of these randomly, one of these 3 will be randomly selected, and then it takes that value and spawns that. So this is applicable to all of the spawns because it's performing the same kind of action. It doesn't matter what enemies there are, and that's why it's really good to have chunks like this, because I don't have to keep rewriting code like the rest of this branch. Yeah, so it doesn't matter what classes you have selected, you can just apply it to any of these because it's performing the same action. Random selection, plugging in, done. Yeah, so in our first wave of our first set of waves of, in the first wave of the lowest difficulty, we are definitely spawning the candy corn. And after that's done, what it's doing is it's increasing the spawned. It's increasing by by an iteration of 1 the spawned counter. So what that's doing is now that the oh, oops, there we go. Now that the spawned, the number of characters that are spawned is equal or more than the max spawn, it's completed the loop. So I'm just going to give the player 5 seconds to clear out any enemies and to pick up the drops. And what it's going to do is increase the wave count. So it's going to send the next wave, and then we're sending the we're setting the spawned back to 0. So yeah, we're setting the spawned back to 0 so that it starts counting from 0 again. How about one of the more complex ones? So we've talked about this. We know what all this does. We've talked about all this. Here we go. Here's where we were before. So selection of 1. So that's either side. So that's what we're going to do. I'm sure you guys have gotten used to seeing this before. Is anyone watching? Is anyone out there? Oh, there we go. Okay. Yeah, so we've seen this a lot before. We've got this array, we're checking the length, we're selecting a random number from that length, and then we're taking it. So we now have our spawn box from either one of the sides. So what I've done here, and this took me so long to figure out because I was trying to compare it, and then it was taking from the top, I was trying to compare it compared to a vector. So I took a random point, I took a specific point and said, if it's close to this point, do this. But that really didn't work because I had things from the top spawning sideways, and then, you know, you can't hit it because it's literally off screen. So yeah, that didn't work. So let's get back to what actually works. So I've taken the spawn box, I have broken it into a vector. So this point now has, I mentioned before, like x negative 150. So we're comparing it. We are comparing it to 400, and because it is less than 150, Wait. Yes, because it is less than 150. I just had to kind of rotate in my head. It is going to be spawning on the left side, which means we need to rotate it on its right side. So it's less than, and we are spawning this enemy on its right side. And I'll explain why this rotation in probably a later video. But yeah, that's really important to figure that out. And the reason why we're comparing it to 400 is if we go back and have a look at our spawn boxes, or these bounding boxes, we've got 500 with a possible width of 50. So it could be, it's going to be 450 either side, but we know for sure that nothing is going to spawn at 400 because it is beyond. It is beyond. Oh, my brain farted. It is beyond what? It is beyond the right vector, but not before. But before the left vector. No, beyond the left, beyond the top vector, but before the right vector. So we know it's going to be either right or left in this case. So if it's more than 400, we flip it onto its left side, so it moves towards the left, and then flip it onto the right, moves towards the right. And same thing, spawned. All right, I think you guys would have a pretty good grasp on what would be happening here on the all sides. Same thing, get if it's more or less than 400. If it's more than 400, flip it onto its. Wait. Oh god, I have to do this every time. If it's more than 400, flip it onto its left side. If it's equal to 400. Oh wait, if it's more than 400, compare it to negative 400. If it's less than 400, flip it onto its right side, or left side. Oh wait. More than 400, which means it's on the right side, means it's being flipped until its left side. Yep. I'm sure you guys can grasp it. If anyone doesn't, they can definitely comment and leave me a message, and yeah. Or if it's equal to 400, it's probably going to be in the middle. So we've got no flipping here because this isn't getting a rotation. So it's more than negative 400, or if it's less than negative 400, it's going to be flipped onto its right side. So, and yeah, we know what happens at the end here. Once again, this all looked very complex, but all that it was what kind of thing are we spawning? Where are we spawning it? Where are our spawn locations? Where are we spawning this specific thing? And then, you know, taking all that information that we collected and putting it into the spawn code, and then increasing that. So, and then that increases the wave count. So this same thing happens here. So we have a wave 1, 2, 3, 4, 5, 5, and then what happens at 6 is we iterate the difficulty up by 1. We set the wave count back to 1 and give the player 3 seconds to, you know, just settle in. So yeah, it's actually pretty simple. Exactly the same thing happens. All that I've done here is put a hard change one enemy so that there's some variety, and you know, I've just mixed it up a little so the person that's playing, you know, kind of has doesn't know what to expect next, unless you've seen this. And yeah, so this needs a little bit of updating, so I'm going to do that now. 3 don't restore. Yeah, so this and I think that's all of this covered. Like, it looked really complicated when we first started looking at it, but when we broke it down piece by piece, we could see that all these individual functions you know, they did their own thing. I think and I covered everything here, and yeah, it took it took 2 videos, but like I'm hoping most of you understand, and if you don't, feel free to send me a message or um, message me on Twitter or send me a whisper on Twitch, and I'd be happy to, you know, kind of explain a little bit further within reason. What's this? Oh, so this is so we have this event graph which picks up information from others, but we also have these miniature things. So these are kind of like functions. These are kind of like procedures within. So it's the exact same thing. It's the exact same thing that I did before, but I wouldn't recommend doing it this way because it doesn't have any time loops because it's not happening within the game space, it's happening within the space of the object. So I'm just going to delete this now, but I'm hoping some of you can at least read this. If it's not game over as game mode, reduce the drop chance. So yeah, you can already start reading code now, and that's really great. I'm just going to delete this. Enemy counter. What's this? Oh, that's just empty. I must have just started doing it. Cool. Alright, so we've taken a look at the player's ship, and that's all ready. Oh yeah, we spawned a bullet, and we didn't actually even talk about what a bullet was. So, the reason why we had to use the player rotation is this. So an event tick happens every frame. So that's your game updating and taking all the information and updating it every frame. So it's usually like 30 or 60 frames per second. So once every 30 seconds, one every 60 seconds, this happens. So what's going on here? So we're setting the actor relative location. So what that means is that it's taking the taking the location relative to the actor at the time. So in 3D space, we have two different ways of measuring distance. So we have the world space, which is, you know, we use this most often. Actually, this is really easy to compare to how we measure distances. For example, we know that Rome is in Italy, or we know that, you know, so we have coordinates for that. So that is its world space. And then we have relative distance. For example, there is a park roughly 1 kilometer from where I live. So that is relative to me. It is from my location, it is 1 kilometer away. So it's the exact same thing here, except in 3D space. I'll talk about child and parent classes later, because that's where that's gonna really mess with your brain. But what is our new relative location? So we're gonna follow this backwards all the way till the end, and we're grabbing the actor rotation. So it's been spawned. So how about we launch a bullet and see what happens? We are launching a bullet, and it's going straight. We rotate our character a little bit, and so it's taking the player's rotation and using that and spawning it from the rotation. It's spawning at the same rotation as the player. So we got that rotation, and we get the up vector. So if we remember our axes, the up vector is the z, so that's the up and down. So it's grabbing the z vector, and we are multiplying that vector by the speed. What speed do we have here? We've got a speed of 10. Now the important part of, so I'm going to set that to 1. The important part of why we need to multiply it by speed is because when we set it to 1, it's not particularly, you know, engaging, is it? To just, there we go, got off screen. So we're going to set that back to 10. So that's the speed that we want the bullet. So we're multiplying the speed by the up vector. So we're taking the direction and the rate that we want to move, and we're adding it to the current location. So we're taking a rate, a direction, and a previous location. So that is the relative movement. So this next part is really important because this stops the bullet from being on screen forever. Otherwise, your game would slowly be over encumbered with just lots of rogue bullets just being, 3,000 units off the screen. So this is how we prevent that. Again, we are comparing, and so we're grabbing the location of the actor. We're breaking this up. So we're taking the z-axis, so the up and down. We're comparing it with 300, so that's off the screen, 300 units from the bottom. And if it's more than 300, we're destroying the actor. And then we're running another test because, destroying it is all very good when it's just moving in the direction, but let's say we've fired just off to the left, and it's going to take so long for it to reach 300 as the reach 350 in the z-axis. So the way we fix that is we take the x-axis and we go off screen -500 or +500. So if it is within this range in the x-axis, or rather if it is no longer within this range, then we destroy it. So that saves us from making a box either side. We just say if it's here. Oh, actually, that's a really good idea to do here, now that I think about it. Because what if someone, and I'm not saying that's the thing, we have to prepare for players to do dumb things like this. And, let's just, there we go, fire from underneath. And, people will do that. So that's something. Oh, I know, I will fix that. I'm just going to make a note of it now because that is a bug. Okay. Lose screen. Try again, not working. There we go. So we'll start making note of that as we go. And so that's what the bullet does. And it has a, let's just have a look at it. We've got the hitbox. It's looking pretty good. We got the hitbox. It's looking pretty close, I've got to say. And we've got my little corn bullet, my little corn kernel. So yeah, that's looking pretty good to me. You'll notice that it doesn't have any kind of collisions here, although it's got like a collision object. And the reason for that is it is acknowledged as oh, this is really important to tell you guys. Class defaults down here, and tags. So under actor tags, it's considered a bullet. So remember how in the player ship you'll do. We had these tags, so we are getting all actors with tag, and that's how you add a tag. You go under here and you add one here. So that's how you want to separate groups of enemies. So like I've just explained, bullets, ammo, items, enemies. And there's no collisions because nothing changes to it when it collides with anything. So how about we have a look at something that does have a lot of collisions and a lot of collision types to respond to. We'll go back up to my blueprints and we're going to start looking at enemies. So there are a lot of them there, but you'll notice I did something a little bit clever to reduce the amount of code that each one needs. So I'm going to have a look at enemy parent. So this is so To explain what this an enemy parent class is, a parent class is something that it will just like when kids get born, and if you've got someone with dark hair and blonde eyes, and someone with like blonde hair and brown eyes, it'll get the traits of the parents. It's the same thing here. So this parent has behaviors that the children will adopt. So we've got here, we don't have a tick, we don't have a collision, but we do have a procedure here, an event that gets launched. Let's have a look at what this event does. Enemy death. When an enemy dies, we are destroying the actor. We are playing a sound. We are causing an explosion animation, which does not work yet and is not my priority.